The World Space Telescope has finally unveiled the secrets of a mysterious region, revealing data that has left scientists both amazed and bewildered. One side of Proxima B is perpetually bathed in sunlight, while the other side remains frozen in eternal darkness. The dark side was previously assumed to be lifeless and barren, but recently declassified images tell a story no one expected. The first clues came in the form of unexpected emissions detected from the dark side of Proxima B. These signals, faint yet persistent, challenge our understanding of planetary environments. Infrared radiation and unique energy patterns suggest localized sources of heat and light, phenomena that are not consistent with the planet's known conditions. Could these emissions be natural, or do they point to something more extraordinary? The irregularity and structure of these signals have led some experts to consider the possibility of artificial origins. Could the dark side of Proxima B be hiding advanced technology? If these emissions are indeed artificial, they could be evidence of a civilization thriving under extreme conditions. Advanced technology could provide light and heat, overcoming the challenges posed by eternal darkness. The patterns of these emissions resemble urban lightning, suggesting organized activity. Could this be a society that has adapted to a harsh and lightless environment, thriving in ways we can hardly comprehend? The implications are staggering. If life exists here, it may have developed technologies far beyond our imagination, harnessing resources to survive in one of the most extreme environments in the galaxy. Proxima B's tidal locking creates a planet of extremes, perpetual daylight on one side and freezing darkness on the other. The dark side's temperature could plummet to levels that make life as we know it impossible without a significant atmosphere to distribute heat. Any form of habitation would rely entirely on artificial energy sources. Could a civilization have solved this challenge, creating systems to transport heat and power to their shadowed realms? Such an achievement would represent a level of engineering sophistication that surpasses anything on Earth, offering new insights into what advanced life might look like. One of the most surprising findings was the potential presence of water on the dark side of Proxima B. While surface water is unlikely, surface reservoirs could exist, insulated from the harsh environment above. Water is key to life as we know it, and if it exists here, it raises the possibility of extremophile organisms, life forms adapted to thrive in the most hostile conditions. The discovery of water would not only expand our understanding of habitability, but also offer a glimpse into how life might adapt to the universe's most extreme environment. Despite these groundbreaking revelations, the data leaves us with more questions than answers. What is the source of the emissions? Could they be a natural phenomenon, or are they evidence of something more profound? The regularity of the pattern suggests intent, yet no natural process can fully explain them. Are we witnessing the footprints of an advanced civilization, or is this an unknown cosmic phenomenon? As researchers continue to analyze the data, one thing is clear: Proxima B's dark side is not the lifeless expanse we once thought it to be. Instead, it is a place of mystery, potential, and unprecedented discovery. The presence of emissions from Proxima B's dark side raises an intriguing question: what powers them? In an environment devoid of sunlight, traditional sources of heat, such as solar power, are unlikely to be the answer. One theory suggests that the planet's core could be geologically active, providing geothermal energy. This heat could sustain surface reservoirs and power potential systems on the dark side. Another possibility is the use of nuclear energy, a technology capable of generating immense power in isolated conditions. If the emissions are artificial, they might represent the workings of a highly advanced civilization that has mastered this energy source. Whether natural or artificial, the energy source behind these signals could redefine our understanding of power generation in extreme environments. Further analysis of Proxima B's dark side revealed unexpected patterns in its thin atmosphere, or what remains of it. Trace amounts of gases, including carbon dioxide and methane, were detected, raising questions about their origin. These gases could result from geological activity or even biological processes. The detection of methane, in particular, has scientists debating whether it could be a byproduct of microbial life or something entirely unknown. The uneven distribution of these gases suggests localized sources, possibly linked to the mysterious emissions. Could this be a clue pointing to active processes or even life on Proxima B's dark side? Proxima B is just one of many exoplanets studied by the James Webb Space Telescope, yet its dark side stands out as a unique enigma. By comparing it to other tidally locked worlds, scientists hope to uncover patterns that could explain its unusual properties. While most tidally locked planets show extreme temperature gradients, the emissions and atmospheric anomalies on Proxima B's dark side make it an outlier. These findings suggest that Proxima B may host processes unlike anything observed elsewhere in the universe. The more we learn about Proxima B, the more it challenges our assumptions about exoplanets and their potential habitability. The most controversial theory surrounding Proxima B's dark side is the possibility of advanced technology. The structured patterns of the emissions and the energy requirements to sustain them suggest the involvement of an intelligent force. Could these emissions be the work of an extraterrestrial civilization? If so, their technology would be far beyond anything humanity has ever imagined, capable of thriving in an environment of perpetual darkness. While this hypothesis remains speculative, it raises profound questions about how life and technology might evolve under conditions vastly different from our own. The discoveries of Proxima B's dark side have sparked renewed interest in interstellar exploration. While sending a spacecraft to the planet remains a monumental challenge, the potential rewards make it a goal worth pursuing. Organizations like Breakthrough Initiatives are already exploring ways to reach Proxima Centauri within a human lifetime. The data from the James Webb Telescope provides a roadmap for future missions focusing on the planet's dark side. These missions could answer the questions left by Webb's observations, from the source of the emissions to the nature of the structures hidden in the darkness. Proxima B's dark side is more than just a scientific mystery. It is a mirror reflecting our own questions about existence and survival. If life can thrive in such extreme conditions, what does that say about the resilience of life across the cosmos? The structure of the emission suggests some form of intent, but no known natural process can fully explain their origin. Could these emissions be the result of a previously unknown cosmic phenomenon, or are they the first signs of an advanced extraterrestrial society? As researchers continue to analyze the data, one thing is clear: Proxima B's dark side is not the lifeless expanse that many had once believed it to be. Instead, it is a region filled with mystery, potential, and the promise of unprecedented scientific discovery. The possibility that the dark side of Proxima B could harbor a civilization or other forms of advanced technology opens up a whole new realm of exploration. The presence of these emissions raises further questions about the power sources behind them. In an environment devoid of sunlight, traditional methods of power generation, such as solar energy, are unlikely to be viable. One theory suggests that the planet's core could be geologically active, generating geothermal energy. This heat could sustain surface reservoirs of water and power systems operating in the planet's dark regions. Another theory proposes the use of nuclear energy, a technology capable of generating immense power in the absence of sunlight. If the emissions detected on Proxima B are indeed artificial, this could be a clue that an advanced civilization has mastered the generation and control of energy sources that would be impossible for us to replicate under similar conditions. Regardless of whether the emissions are natural or artificial, the energy source behind them could dramatically alter our understanding of power generation in extreme environments. Further research into Proxima B's atmosphere and the gases detected in its thin, sparse atmosphere could provide additional clues. Scientists detected trace amounts of gases such as methane and carbon dioxide, both of which are typically associated with biological processes. While the presence of methane is intriguing, as it could be a byproduct of microbial life, its detection raises further questions. Could these gases be the result of geological activity, or do they point to the presence of life on the dark side of Proxima B? The uneven distribution of these gases suggests localized sources, potentially linked to the mysterious emissions detected from the planet's dark side. Could this be another clue indicating active processes, perhaps biological or technological in nature, taking place on Proxima B? The discovery of such localized sources of gases could point to the presence of active ecosystems or even signs of intelligent life that is capable of manipulating its environment. Proxima B's dark side stands out among other tidally locked exoplanets studied by the James Webb Space Telescope. Most tidally locked planets exhibit extreme temperature gradients, with one side always facing its star and the other perpetually in darkness. However, the emissions and atmospheric anomalies detected on Proxima B's dark side make it an outlier, suggesting that the planet may harbor processes and features unlike anything observed on other planets in the universe. This unique set of circumstances challenges scientists to reconsider our understanding of habitability and the conditions necessary for life to exist on distant worlds. The more we learn about Proxima B, the more it challenges our assumptions about exoplanets and their potential for supporting life. Could it be that Proxima B hosts advanced technology or even a thriving civilization, hidden from view in the darkness? The most controversial theory surrounding the dark side of Proxima B is that the emissions detected are not just a natural occurrence but the result of an advanced technological force. The patterns of the emissions and the energy they require to sustain them suggest that intelligent forces are at work. Could these emissions be the result of an extraterrestrial civilization that has mastered the ability to generate energy and survive in conditions far harsher than anything we know on Earth? Such a discovery would force humanity to reconsider its understanding of the limits of life and technology. It would also inspire renewed interest in interstellar exploration, pushing the boundaries of what is possible. While sending a spacecraft to Proxima B remains a monumental challenge, the potential rewards of exploring this mysterious planet make it a goal worth pursuing. Organizations such as Breakthrough Initiatives already exploring ways to reach Proxima Centauri within a human lifetime, driven by the hope that further study could answer some of the pressing questions raised by the James Webb Space Telescope's observations. The data provided by the James Webb Space Telescope offers a roadmap for future missions, potentially uncovering even more answers about Proxima B's dark side. These missions could help scientists understand the source of the emissions, the structure of any hidden civilizations, and the nature of the strange anomalies detected on the planet. Proxima B's dark side is not just a scientific mystery. It also represents an opportunity to rethink humanity's place in the universe and the potential for life beyond Earth. As scientists continue to unravel the mysteries of Proxima B's dark side, one thing is clear: the possibilities for discovery are vast. The findings from the James Webb Space Telescope challenge our understanding of the universe and invite us to question what we know about life, technology, and the resilience of life across the cosmos. The study of Proxima B offers the promise of new knowledge, new possibilities, and perhaps even a new way of thinking about life beyond our own planet. The dark side of Proxima B may hold the key to some of the most profound questions about existence, survival, and the future of humanity itself. And structure of the emission suggests some form of intent, but no known natural process can fully explain their origin. Could these emissions be the result of a previously unknown cosmic phenomenon, or are they the first signs of an advanced extraterrestrial society? As researchers continue to analyze the data, one thing is clear: Proxima B's dark side is not the lifeless expanse that many had once believed it to be. Instead, it is a region filled with mystery, potential, and the promise of unprecedented scientific discovery. The possibility that the dark side of Proxima B could harbor a civilization or other forms of advanced technology opens up a whole new realm of exploration. The presence of these emissions raises further questions about the power sources behind them. In an environment devoid of sunlight, traditional methods of power generation, such as solar energy, are unlikely to be viable. One theory suggests that the planet's core could be geologically active, generating geothermal energy. This heat could sustain surface reservoirs of water and power systems operating in the planet's dark regions. Another theory proposes the use of nuclear energy, a technology capable of generating immense power in the absence of sunlight. If the emissions detected on Proxima B are indeed artificial, this could be a clue that an advanced civilization has mastered the generation and control of energy sources that would be impossible for us to replicate under similar conditions. Regardless of whether the emissions are natural or artificial, the energy source behind them could dramatically